Hi my Lagrangian friends, how are you? Let's now write Lagrange equations in Cartesian coordinates and then change those to another set of coordinates. With this you will see how Lagrange equations do not care about the coordinates you use. They are general as they come from a profound and also beautiful principle. So you can use your principle of free will and choose your favorite coordinates for each problem, knowing that the result, as expected, is coordinate independent. Let's call q sub I and q dot sub I to the new coordinates and their velocities. I know that Lagrange equations hold for Cartesian coordinates. We showed this in a previous video. Now I want to show that in these new coordinates they also hold, because we can write one set of coordinates as a function of the other set of coordinates. The partial derivative of the Lagrangian with respect to q dot is the partial derivative of the Lagrangian with respect to each of the Cartesian velocities times the partial derivative of the Cartesian velocities with respect to the new velocities q dot. Let me now rewrite the Cartesian velocities. These are the derivatives with respect to time of the x sub I coordinates, which they are also the partial of xi with respect to qm times the derivative of qm with respect to time, plus the partial of xi with respect to time. It's just the chain rule for x that depends on q's and on time. If I now do the partial derivative of this result with respect to q dot, I get this. Now I can substitute this in the first expression I wrote and I apply the derivative with respect to time. The first term on the right-hand side of the equation can be rewritten using Lagrange equation for Cartesian coordinates. For the second term, we have that xi is being derived with respect to qm and with respect to time. I can switch the order of these derivatives. And this final result, if you look at it close enough, you will see that the right-hand side is actually the partial derivative of the Lagrangian with respect to qm. But this is just what we wanted to demonstrate, that Lagrange equations in Cartesian coordinates also imply Lagrange equations in other coordinates. Lagrange equations are cool. May the science be with you.